In the previous video, you learned how to use the two functions from tidyr, pivot_longer and pivot_wider. We started here with the data set data raw, which was optimized for human readability due to these two columns 2017 and 2018. Then we learned how we can use the function pivot_longer to make this relatively wide data set longer and to come up with this longer version of the data set, which is only one step away from tidy data, because now we only need to make it wider in the sense by taking the names from the column indicator and the values from the column observation and basically shift everything a little bit to the right. We did that by using the function pivot_wider from tidyr to finally come up here with a tidy data set. Now, if we look again at the various steps, so coming from here, going this intermediate step, finally reaching the final tidy data set, you might wonder whether you really need to make these separate steps, or whether there isn't an option to directly go from this data set to the final tidy version from. And the answer is yes and no. The answer is no in the sense that no, the separate steps are required, and they are actually also helpful because they help us to split the bigger problem into smaller steps that are easier to comprehend, and therefore it's easier to avoid mistakes. But on the other hand, the answer is also yes in the sense that we can come up with a code which we only need to execute once, which basically takes care of all the different steps, and which in the end is also a little bit easier to read once everything is finished. And to write this code, we need a concept called the pipe. Now, there are many different pipes in R. There's actually a whole package, macrotar, which provides you with various versions of pipes. Here we will use one particular pipe, and when I say pipe, what I mean is combination of certain tokens, namely the percentage sign, the greater than symbol, and the percentage sign again. If you type this combination of tokens, you will see how the color of it is changing from black to gray, meaning that you now have created something called a pipe, a particular token or a particular keyword. And this pipe basically helps us to take these two steps, or these three steps actually that we have here, and to merge them into one. Just a disclaimer from the beginning. In practice, I strongly recommend you to first of all develop your data preparation strategy stepwise and to implement the single steps as we've done so before. But once you've done it, I also recommend you to translate this into a pipe version which is easier to read and easier to extend. But before we translate this here into a pipe version, it's better to let's start by understanding how the pipe actually works. Now, I always try to remember the function of the pipe in the following sense. So you write something, some code on one line, here on line 50. And what the pipe does is, pipe comes always at the end of a line. What the pipe does is, it takes the result of this line and throws it into the next line as a dot. What do I mean by that? It means that in this case, the result of this line is just the dataset raw itself. What the pipe does, it throws it into the next line as a dot. By this I mean that I can now write a function and refer to the result of the previous line directly by writing a dot. So, for instance, remember this function head. The function head can be used to give us a preview of a data set. In this case, let's check it out with data raw. We can provide here the second optional argument n by writing the number of lines that we actually want to see. So in this case, this function call here taking data raw as the first argument and n equals 2 as the second argument, returns the first 2 lines of the data set data raw. You can write this using the pipe, because this pipe here takes the result of line 50, data raw, throws it into the next line as a point. So I can just write a point here, and then add the second argument n equals 2. And if I execute this here, I get exactly the same result. This is how the pipe works. At first sight, you might say, okay, so you're telling me that this here does the same as this. So why should I care? Obviously, this is a very dumb example, because probably this is much easier to read than that. But you might already imagine that this pipe here can be extremely helpful if you want to chain several steps in the data preparation process, such as here. So let's turn to a more interesting case by translating these 2 steps here into a pipe version. So we start here with our baseline data set, data raw. We now want to take this data set and throw it into the next line. In the next line, we then want to call the function pivot longer. So what we do, we write the pipe, we go into the next line, and we then write our pivot longer call. Now here we've written data equals data raw. What we now need to do is we write data equals dot, because data raw is thrown as a dot into the next line by the pipe, and then the rest actually can remain exactly the same. And if we execute this, we get exactly the same result as if we call it directly by specifying data raw here explicitly. Could go even further, because if the dot here is used as the first argument of the function that we're about to use here, which in 90% of the cases is the case, could even remove this line 52 here and only make the following function calls. So what the pipe does here, it basically throws data raw into the next line. This next line starts with a function called pivot longer, and the first argument used by pivot longer will automatically be what has been thrown into this line via the pipe from the previous line. So in this case, the data set data raw. So this call here is the same as this part of the code above. And it's nice in terms of readability, because you start reading on line 50, you know, okay, I start with the data raw, then I call pivot longer, and it does this. So it's nice because you can read the working of the code on the data set from top to bottom. And you can add more pipes to this. So we could add a pipe here, and this then takes the result of the previous line. So in this case, the result of this line here, it's the result of the function called to pivot longer, takes it, throws it into the next line. And now in the next line, can basically take here our pivot wider call, can remove here the argument data, because this pipe automatically throws the result of this line into the next line. So we do not need to specify data explicitly. It's done by the pipe. If we execute this, we actually come up with our final tidy data set. So in some sense, the pipe helps us to merge together these different function calls. And the good thing is that it's very, very easy to read. So you start with data raw. The pipe indicates, okay, a next step is coming. So I take data raw, I use it as a first argument to pivot longer. Then you see here, again the pipe. Then the next step is I use the result from pivot longer for the next function called pivot wider. It might be even easier to read if you add an additional line break here. So what the pipe does, it helps you to chain different steps in the data preparation process and makes it more readable and also easier to execute, because you do not need to execute these different steps separately. You only need to execute this once. If you assign a name to the final product, so in this case here, data, let's call it tidy data piped, it's also much easier to read, because you say, okay, that's the name of the final object. And this final object is created in the following way. We start with data raw, we call pivot longer on data raw, and the result from the pivot longer call is then passed to pivot wider. So this is something that's quite straightforward to read, and that makes very explicit how tidy data piped is created by starting from data raw and applying these different steps. So I recommend you in practice, if you know that you want to start from data raw and you want to create a tidy data set, my recommendation would be start by coding the steps one by one so that you can have a look at the intermediate results. But once you're finished, translate the whole thing into a piped version, because that's easier to read and easier to execute, and more ease always means less errors. If you have a piped version in front of you and you want to see the intermediate results, what you can always do is you can start from the beginning, you can mark the text and then click on run or use the shortcut, because then R will only execute here the marked part of the code. So even if you've written your code in pipes, you can still have a look at the intermediate results by using this feature of RStudio, by marking code before the pipe, clicking on run, and then having a look at the intermediate result. So pipes are so straightforward to use, and I would say they improve readability so much that I tend to use them even if I only make one function call. So even if I was only making this pivot longer call to data raw, I tend to prefer to read it like this as compared to this version here. Why? Because in this version, it's not that, I mean, you can read it, but it's not that explicit that you start from data raw and then make the pivot longer call. Here, it's really straightforward. I see, okay, I have the object called tidy data pipe. I start with data raw, and then I take it and apply pivot longer to it. So it's just something that's easier to read. In the end, you need to decide for yourself, especially when we use more than one step. I think there's a strong argument for using the pipes in terms of readability and transparency of the code, which is why from now on I will use them quite regularly. So don't be surprised. It's fully okay if you decide you don't want to use the pipes so much as I do. But my personal recommendation would be to invest a couple of minutes to make a couple of exercises and to exploit this power of the pipe in terms of readability in your daily work, because it really will make reading code for you and your collaborators much easier.